Welcome, everyone, to the Arcus Annotation Initiative, maximizing the value of label data at CHOP for AI and machine learning research. I'm Janae Lukey, the Data Catalog and Discovery Librarian on the Arcus Library Science team, and I'm joined here by Scott Haig, Supervisor of the Arcus Applied Data Science team, and Miriam Danieli, a data scientist also on the Applied Data Science team. Allison Olson, who is an archivist on the library science team, will be managing the chat, as well as adding in some links related to the content that will be presented today. So today we will provide an overview of the Arcus Annotation Initiative, explain the importance of annotated data, showcasing ongoing annotation projects, and share how you can contribute and benefit from this valuable resource. And more of a housekeeping note, feel free to ask questions in the chat throughout the presentation, and we will be sure to address them at the end during the Q&A portion of today's talk. And now I will pass it over to Scott.
Yeah, thank you very much. I'll just give a sort of a brief intro to the rest of the presentation, and then I'll hand it off to the real experts. What is the problem we're trying to solve here? One thing that we've been thinking about as we work within Arcus, over 150 research projects, we see a lot of similar trends. And that really, the process of pediatric research really starts within Arcus and lots of other places with the electronic health record. And that record is a mix of structured and unstructured data that is collected as part of the normal operations of the hospital system. So it's all types of measurements and clinical notes, as many in this room know, and also the treatments and the tools that are used to help our patients become well. So this is a very complex data environment from a computational perspective, and it includes so much unstructured data in so many different modalities that it becomes complex to build precision medicine AI structures on top of it. So that's the environment we're in, which is data rich. And the challenges we see, if we want to move to the next slide really quickly, the challenge we see can be sort of described here, which is a very linear pipeline. So a lot of the Arcus omics work happens this way, where we collect genetic data, we run it through a sequencer, and we get reads out, genetic reads out. And then we have to label them by putting them through various pipelines that normalize them and line them up to regular, what we call like normal genomes or HG38, and then we can identify variants. So we've gone from this very unstructured data, which is all of the reads, through a very complex process, and we now have variants. And now we have to apply knowledge and different statistical techniques to identify which of those variants can actually cause different conditions. And not just specific variants, but also the really complex combinatorial relationships between the many variants. So this is just one example of how labeling happens within the genetics world. And I think there's a lot to be learned here from how the genetics, how the omics side of research has done a sort of a very good job of creating systems to share labels in a way that you won't necessarily see from something like note annotation in as detailed a way. So there's lots of databases out there where you can pull variants and use them as standards to compare to other genetic data. But again, this is very linear, and it doesn't really talk about some of the multimodal problems we have. Next slide, please. So what do we see within Arcus, or at least on our research work? We see a lot of research projects that come in and want to look at a single type of data and to annotate it. This, as Dr. Denali will explain in her discussion a little bit, this is often a large percentage of the work that happens within any research project. And the challenge is that because it's such a large percentage of work, and it costs us so much to do this annotation, going from, say, a raw note to a human phenotype ontology, or a raw note to a pediatric gait score. These are just some examples of hundreds and thousands of different annotation projects that are happening. Because that is so complex in time and the specific understanding of the problem that the researchers bring, this becomes a very, very valuable resource. Particularly valuable because of that effort required to create it. And the challenge is that it's most often locked up within an individual research project. And that has two major disadvantages from my perspective. One, it's not available easily for the next pediatric gait project often. The scores aren't, the labels aren't. The statistical analysis or the regression analysis or the other scientific outputs are often available, but very often the label data is an intermediate product that's not published with the results. So it's locked up, but it's extremely valuable. And the second thing that's really important about this data is that if you want to build precision medicine that is multimodal in nature, then you have to have these labels coming in from many different places. So there's sort of two disadvantages with the current structure we have. And the idea of this annotation initiative is to really try and collect as much of this data as we can, and then share it in a way that allows research to take advantage of all of that hard work and all of that time and effort that's been spent on the individual research projects. So that's the goal of what we're trying to accomplish here. There are parallels to this in the commercial industry that you can see this as a very common problem. If you look at, let's say, the amount of money that companies like Waymo spend on classifying imagery or LiDAR data for driving a car, or Mechanical Turk at Amazon, who has turned this into a whole business model of labeling data. So we see in the AI world that labeling data is a large part of how a company organizes their technology. And if we think about the Research Institute as trying to move ahead in AI, it becomes part of our strategy for taking advantage of things we're already creating, but not necessarily using to the fullest extent. Next slide, please. And then last thing I'll mention is that AI strategy is a very busy place at CHOP now. There is a lot going on. There's enterprise AI strategy. How does the Research Institute and the clinical endeavors work together? Annotations could be a very big component of that as we try and figure out ways to potentially extract annotations as part of our regular clinical work. Cloud strategy, where are we going to do our work? How are we going to do our computations? Where do we get access to the tensor processing units and the graphical processing units that modern AI needs and relies on? And then governance. How can we make sure that we're doing this safely and ethically? All of these are different initiatives that are currently ongoing. And then I just wanted to call out one project that I've been involved with, which is Dr. Campbell's Large Language Model Collaborative, which is really trying to push the boundaries of using language modeling to examine our clinical record. So there's a lot happening, and I'm very excited that everybody's joined us here today. And like I said, I'm going to hand it over to the experts and Dr. Denali. Thank you very much.
Thank you so much, Scott, for the introduction. So in this part of the presentation, I want us to all be on the same page regarding the terms and terminology. Some of you might have already done annotations, so you're familiar with everything. But for those of you who don't have the background, I hope that I can deliver that here. So following up on what Scott mentioned and the wealth of data we have available at CHOP, I want to shift our focus from availability to understandability here. So we have access to an ocean of data. It's from the clinical notes, the imaging, the sequence data. We have research paper. We have an incredible resource that we can use for our clinical care, for our research, and more. And initiatives like Arcus make that available in an accessible liquid at your fingertips. But the problem is raw data on its own can be very challenging for analyzing, to understanding, to interpret it. So I think of it as a puzzle. You might see all the pieces, but how they fit together, how they tell the story is hard, often requires manual review. It requires expertise, knowledge, and it's not ready for a machine learning model or any sort of statistical model to leverage that. Sometimes we have structured data like ICD codes, but even then, they might not be complete. They might not be perfectly accurate. So they're not even ready for any sort of analysis directly. So here, the question is, how can we transfer this ocean of data into insightful and actionable data? And the answer is annotation, which basically tries to add structure and meaning to the data. Next slide, please. So fast forward, by the end of this presentation, I hope that we all understand what annotation is. We see some examples. We understand the power of annotated data, and how we can contribute to this annotation and make the clinical data more valuable and understandable to everyone in the institute and maybe beyond. Next slide, please. Okay. So I want to start with the definition of annotation. So it's basically at its core, it's trying to add meaning to raw data. And then more formally, we can say it's the process of adding labels, tags, notes, metadata, or anything descriptive to the raw data. And here I have 3 examples. The first one is thinking about highlighting part of the clinical note. So maybe you will see a term identifying that there is elevated glucose, and maybe you want to label that as diabetic risk factor. That's an annotation. Maybe it's not the note, maybe it's an ultrasound or an MRI, an image. It could be finding a part of that image which may indicate something important, like a brain tumor. Or it could be as simple as adding a symptom to a chart. So coughing might be something that you add to the chart, and it's important, and it adds additional information, and it can be translated into a structured format. But these are just simple examples. It could be any sort of modality you can think of. It could be time series or omics and more. But here, the fact was to understand annotation. And then now let's talk about annotated data. This is the data that has the annotation on top of it. So for example, it's not just the MRI, it's the MRI and its label here, brain tumor. It's not just a sentence, it's the sentence and the medical term or the phenotype on top of it. And the key takeaway here is that annotated data is the enriched data specifically made for particular analysis or workflows, and it's often considered as gold standard data and can be used to uncover patterns, especially through machine learning systems. Next. Okay, so there are a lot of terms that people use, and I wanted to bring them here, maybe not all of them, but some of them that I'm familiar with, so that we are on the same page. So we have annotated data, labeled data, tag data. They are basically the same process. It's about adding label and metadata to raw data, and could be on many different modalities. And then we have gold standard data, which is a type of data that usually is used for statistical model training and evaluation. That's highly accurate and reliable. And then we have ground truth data. That's the basic truth. It's the answer to the question. For some projects, however, or for some questions, we don't really have one answer, or we don't have the definitive answer with the questions or the data points we have at hand. So sometimes we don't have this ground truth data at all. But the key takeaway here is that the training data, the validation data, test data for the statistical models can be part of these annotated data. Next. Okay. So in this slide, I want to focus on why annotation is important, starting with the fact that it makes the data actionable. So it turns raw data into actionable items and information, and it makes them understandable, not just by humans, but also by machines, and make the interpretability a lot more easier. It makes the data searchable because of that structured component that it adds. You can look for specific labels, you can look for patients that are going under a specific treatment or their responses to that treatment and anything around that. It makes it analyzable because of that structured format. Now you can use them for any sort of statistical analysis. And then it makes it reusable, which is very important because a lot of effort, as Scott mentioned, goes into that annotation, and we don't have it often for the clinical data. And then it's very important to be able to use that data for another projects. Sometimes you can think of it this way, that a target cohort for one project could be the control group for the other, or the benchmark for the other projects. And then ultimately, the annotation tries to transform the unstructured and semi-structured data into valuable structured assets that can help understand patterns from clinical data. Next. Okay. So now in this slide, I want to talk about some general applications for annotations we have been already part of. So you might not recognize it as an annotation, but at its core, it really is. On your phone, you might have this photo app that allows you to tag people. And it might start with validating some questions. So starting with your contact from pets or people, it will assign images based on that few number of annotated images you give it to them. And then it could be something not very sophisticated, but very practical, like spam filters, which basically at its core is trying to figure out if an email should land your inbox, it should go to the junk folder. And it does that by looking at the sender, the subject line, or the content of the email. And sometimes it doesn't do well. So an email might land in your inbox, but you have this option to label it as junk. And then it will help the machine learning system behind the scene to do it better next time. CHOP asks us to report phishing emails, for example, here for validation purposes and also for training purposes. So those are not very fancy examples, but real world example that we have all been doing that. Next slide, please. But you might have done it for your research purpose as well. So I talked a little bit about some of the examples that can go into the machine learning pipeline, but I can talk a little bit more here. So any sort of annotated data can be used in statistical models, and by Scott's presentation, you already are thinking about AI models. It can be used in various training and validation workflows from supervised training, fine-tuning, reinforcement learning, and more. I won't go in depth here, but I'd be happy to take questions afterwards. And then it doesn't, sorry, previous. Okay, so it doesn't have to be statistical models. It could be anything. Even if you don't have a statistical component in your analysis, you could benefit from annotated data, for example, to find the cohort of study you're looking for. Next slide. Okay, so now in this slide, I want to talk about the different terms that we hear every day, but they can be used interchangeably, but they're not really. So in the bigger, broadest concept, we have artificial intelligence or AI, which is basically all the techniques that try to make machines think like humans at human level intelligence. We're not there yet. And then underneath it, we have machine learning, which is a type of machine learning, which is a type of systems that try to do end-to-end analysis and learn patterns from data, but they don't really need that human level intelligence. And then we have deep learning, which is a set of artificial neural networks that are deep, many that they have many layers. And then underneath them all, we have large language models, which are a subset of deep learning models, but then they're mainstream now. The key takeaway here is that annotated data can help and benefit all of these. It doesn't have to be very sophisticated system. It doesn't have to be at the level of AI, but it can be used in any of them. So tying it back to our world and applications in our worlds, for example, tumor identification can be categorized as image recognition, and it could go under deep learning, for example, or diagnosis from patient progress nodes could go under large language models or any of these models as well. Next slide, please. So then here, I want to talk about the value of annotated data, especially in healthcare. It, of course, does unlock a lot of potential. First of all, it allows for setting the parameters or training the model. At its core, it tries to update the weights by showing example input and expected output. And then the model will try to do that on the validation set as well. And then we have benchmarking, where we are using a gold standard data to evaluate if a model is doing really well. We don't have it in the clinical workflow a lot. We have it in the general AI, and that made really the AI systems to work better because we have a set of gold standard. But you can think of it as the benchmark that MedPalm, Google MedPalm used for evaluating their system. They used USMLE question and answer to evaluate their system and say if it's working properly or not. Then there is reducing the bias. So when the data is curated by experts, we can make sure that it has representations for all demographic groups, and it has minorities also represented in the data, and the model could potentially do better. And then lastly is reducing the hallucination. This is more relevant to the LLM world, but it can be applicable to any sort of AI model. So a lot of these models, they answer any question you ask them, and they may look confident, but they're just hallucinating. So there are techniques to use annotated data and tie it back to that annotated data before answering questions so that we can have a little bit more reliable answers from them. Next slide, please. So now we talked about the terms and the importance. I want to talk about other sort of applications that annotated data could be effective in this clinical and medical research. So we talked about example in diagnosis, but doesn't need to be just diagnosis. Sorry, could you please? Okay, thank you. So it could be annotating symptoms, it could be diagnosis, treatment, medication of the patient, anything that goes into the clinical documentation and would make it easier for searching, for analysis, for reporting. Then we have resource cohort building, which I touched on, which allows you to benefit from the annotation to find the cohort that you want to study. Then there is clinical trial, which uses that structured annotation to help find patient responses, adverse effect, protocol deviations, and more. And then there is the fact that every research team or organization or hospital might have their own way of annotating or using the different languages. Having a standard here will help them speak the same language. Then we have public health, which is trying to tracking the diseases and their spread and treatment using the annotated data. And then at the end, we can also think of annotation as a way to improve data quality and see if there are inconsistencies in the data. Next slide, please. Okay, so in the next 3 slides, I will be presenting real world examples, real CHOP Arcus examples on different modalities to help you be introduced with the researchers who are using these tools for their research. So the first one is on text modality, and it's led by Cliff Thornton and Allison Lay. I believe Cliff is in the chat, so if you have questions, you can reach out to him. But what are they doing here is that they're looking at patients who are going under chemotherapy treatment, and a lot of these patients may have some side effects during their treatment, and these side effects may be at the level that the physician may decide to interrupt the treatment or even discontinue it because of that side effects. So we have some of them in the green box, in the ontology box here. We have neuropathy, constipation, nausea, vomiting, and mucositis. They have different severity level, and it's important to understand them sooner than later in the treatment so that we can have a treatment option specific for that patient. So in the black box here, we have an example of an annotated note, which is looking at a series of words and annotating them with the symptom nausea and grade 2. So we are marking the symptom and also the severity of it with the goal of having an end-to-end machine learning system that can look at these notes and be able to detect the symptom and the severity of it. And it will be helpful because it can adapt the treatment option early on for this project. Okay, so next example is on the image modality. So here we have Joy Legan from Turing and Greg Tajan and team looking at ultrasound. So they're doing 2 distinct type of analysis here on the images. On the left, we have OCR or optical character recognition systems, which try to read text that's embedded on the image. So here the radiologists do their annotation and put them on the ultrasound. Here, for example, in the box is left kidney, and then we also have information about the measurement of that kidney, for example. And the task is to convert them into structured format. So OCR techniques help to read them from the unstructured images and convert them into structured format. That's one example. Then on the right, we have another example of segmentation, which the task here is to find the area of the ultrasound that's looking at the specific organ, or here is kidney. So we have the input image, in the middle we have the mask, which can be applied to that input image and will isolate the kidney from the rest of the image as an output. The mask can be manually annotated by experts, and it can be generated by a machine learning system. But of course, the machine learning system could benefit from annotated data to do better. And why is this useful for their project? Because it can understand the measurement of the organs they are looking for. It can understand the abnormality, and it can also help radiologists. Next slide, please. So the third and the last example I have here is on time series. We are looking at a project Benny Chen from DSBU, Jonathan Mitchell and team are looking for. They are looking at sleep disorders through polysomnography. What they're looking at is there is a schematic on the left. We're looking at different types of sensors that capture data from patients while they're asleep to figure if they have sleep disorders. Those sensors could look at EEG, they can look at blood oxygen level, breathing events, and many more. They're all in time series or temporal format. And for this particular case, they have sensor data from 30 patients, 30 kids. And the task is to figure out if they are at sleep or awake status. What they did was their sleep technicians and physicians looked at these time series every 30 seconds and marked them as awake or asleep, and used that to evaluate off-the-shelf systems. So I have two of them here on the right, but there are more. If you're interested, please look at the abstract that's linked here or reach out to Benny. They used this annotated benchmark to evaluate the off-the-shelf system and see how accurate they are. That's it, please. Next slide. Okay, so I'm hoping that by bringing the 3 real-world examples here, you already are thinking about the fact that this annotation task could be very challenging. So here I have listed some of the things that I think might be important to focus on. So starting with the ontology, first off, you might think of what do I need to tag? What are the relationship between the tags? Do I need to use a custom ontology? Do I need to use a predefined ontology like HBO? How can I understand the concepts and set them for my project? There are also some considerations regarding the rules and guidelines you might provide to your annotators to follow them and be able to get a good quality annotated data. And then there is also considerations regarding pilot execution, training processes, and monitoring data quality over time, as annotation could take a lot long. And then there's also choices around tools, techniques, and software for annotation, which highly depend on the users you have, their skill set, and also the modality of the data. And at the end of these efforts, you want to make sure that you can collect the annotated data, store it in a way that's easy to use for future purposes. It's easy to use for collaborations inside and outside the institute. Those are all the things that you might want to think about. But if you have already experienced them, you know that for this call, we are really excited to have you collaborate your annotated data. But I wanted to also mention that we will have upcoming presentations going in more depth on the ontologies, the rules, how you can use the tools. Arcus already has it for clinical notes. So we'll have another presentation with a real-world application for annotating clinical notes. But I want to hand it over to Jenny to talk about this initiatives and how all of you can contribute to it. Thank you.
Thanks, Miriam. So now for some details on the initiative itself. Arcus aims to create an annotation repository for clinical notes and other forms of unstructured data. Labels and annotated data are costly to create and crucial to machine learning, serving as the ground truth for supervised learning algorithms. And with the organization and reuse of annotations or annotation libraries, it offers a solution for organizations like CHOP to maximize the return on investment on labeling efforts, allowing researchers to share and extend existing investments for their own machine learning and AI projects. So in summary, machine learning projects require a large amount of high quality data, which can be time consuming and expensive to create. And Arcus aims to create an annotation repository for labeled clinical notes and clinical data, expanding to other data types in the future. And the repository of curated annotated datasets that gives CHOP researchers access to high quality, relevant datasets to further clinical research. So what will we do with this data? A couple of quick definitions before diving into the details here. An archive is a collection, whether physical or digital, that is meant to retain and preserve the thing that is being collected for long-term value. Archiving an object or digital data should help prevent its loss. And then the Arcus archives is a specific archive of research data sets and reference cohorts at CHOP, managed by the Arcus team within DBHI. And then a data catalog is a detailed inventory of all data assets in an organization, utilizing the metadata that is collected about that data. It is designed to help individuals find and discover the most appropriate data for any analytical or business purpose. And Gene is CHOP's enterprise data catalog, which is built on the Elation platform and represents data across the CHOP enterprise, including databases and data warehouses. Helix, which is built on Snowflake, is represented, and then as well as analytics assets such as ClickSense dashboards, documentation, best practices and standards, and then our archived research data such as the Arcus archives. That said, annotated data will be archived and preserved as part of the Arcus archives, and information about the annotated data will be collected in an annotation card, like an AI model card, but for annotations. The annotated data research projects, along with the annotation card, will then be represented in Gene as part of the Arcus archives. Through this effort, other researchers at CHOP will be able to discover this work and request it for use in their own research projects. In the next couple of slides, I will show a sample annotation card that relates back to one of the examples Miriam presented. A future goal is to take this a step further and have a customized data explorer for all annotated data at CHOP that can be used in machine learning research. Similarly, Arcus has already created a custom browser for genomic variants, the variant browser, which is what we will use to model this customized data explorer after. And a more public example of the type of browser we are imagining is the UCI machine learning repository. So here we are seeing a sample annotation card as it will display in Gene. This one is for the AGV study time series sleep-wake data research project that was mentioned earlier. The various details we are collecting include an annotation summary describing the overall goal and process of annotating the data, any associated models, as in what model or models is the annotated data expected to run on. Any data set details that includes a description of the cohort of clinical or research data related to patient populations with a notation of the size and extent of the data if known. Inputs and outputs, noting the type of files being annotated as inputs, as well as the end state of the file types after annotation. More specifically, like what data and algorithm feeds into the annotation process, and what is the result of applying annotation to the data. We'll also be looking for method notation describing how the annotations were applied. Was it manually with a script? Who did it? Everything will be noted. And then details on which standards and ontologies were applied to the scripts, to the manual annotation, to the data, or about the annotations themselves. And then continued with reference files that lists the file name of any external files needed to understand the annotated data, a description of any potential ethical considerations, such as the possibility of the annotation skewing better or worse for certain groups, the potential for actions taken from the annotation output to create or exacerbate inequities, etc. And then a description of how the annotated data was validated, evaluated, or how quality was assured during the annotation process. Also, a list of any publications that served as sources of data or which published the annotated data or results of working with the annotated data. And then any other relevant links to the input and output data sets. So what types of data are we looking for? In this phase, which we are actively in, we're interested in clinical data sets with labels as part of the data or annotated clinical notes. In the next phase, we are definitely looking to expand. And if you are working with other data types now and are interested in participating in our initiative, please reach out. And then for what might be most important are what are the benefits to participating for you as the researcher? You'll get support from experienced digital librarians and data scientists. Arcus research data management professionals can help you manage your data and provide guidance on data structure, along with consultation to meet annotation standards. Arcus will provide expert guidance on tailored annotation processes, including collaborative coding, labeling, and high iterator reliability. There will be enhanced collaboration and knowledge transfer. Learn who is doing similar research, share notes, insights, and comments, and achieve greater recognition and higher visibility by publishing your data set to the gold standard data repository, resulting in more high impact data citations. There are also additional benefits to participating for the enterprise. Your annotated data can make a real difference at CHOP. It helps to advance research by providing the necessary data for groundbreaking studies in health and medicine, improve tools by helping to build more accurate and reliable systems, whether for clinical decision support or AI applications, drive discovery by enabling the identification of new patterns, correlations, and insights from complex data, establish standards by contributing to creating shared standardized data sets that benefit the entire research community, and increase data value by turning raw data into a reusable, powerful asset. So what is next for the annotation initiative? Like Miriam just mentioned, there will be a presentation more specifically on clinical note annotation in Arcus, including a demonstration on the standardization of clinical data annotations and how to pull annotated data for reuse. So be on the lookout for communication from us for when this will be scheduled, so you can add it to your calendars. And also, as mentioned previously, the team will be working on expanding into additional data types. So in conclusion, if you have a project that meets what we are looking for, please fill out the form, which I think the link will be added to the chat shortly. And if you have any questions, feel free to reach out to myself or Miriam or Scott or this email address, dlarcuslibraryscience@chop.edu, and we will be able to assist you. And if there's any questions, we can open that up now. And feel free to take yourself off of mute too. No questions. Okay.
Janae, I have one. I want to
Sure.
turn my video off too. Thank you so much for taking the time to present this work. I think this is absolutely where we all need to be heading, and in the spirit of Arcus and getting everyone together and not redoing the same work. Brilliant. One quick question is, are you soliciting from the group their annotated data sets, or are you also offering like a mechanism and a platform for working out how to annotate existing corpus of notes?
Miriam, did you want to take this?
I can pick
I
it
think
up.
it's
Yeah.
both.
Yeah, sure. Thank you for asking. So the main goal of the annotation initiative is to collect the annotated data. But yes, we are looking to help in any way or format. We have already have tools and standards when it comes to clinical notes in Arcus. So if you want to have additional chat, I'll be happy to meet with you and discuss how we can help when it comes to the clinical notes. One of the examples that I shared from the clinical note annotation, Dr. Thornton and Dr. Lay, that's happening inside Arcus. So we have seen some examples, we have some guidelines, and then we also have tools and code to collect the data and use it. So if that's something of interest, we can have another meeting, but we will do another demonstration in an upcoming presentation so that everyone gets a chance to see it.
Fantastic. That's great.
Yeah, just add one thing to that, which is I think from Arcus's perspective, the more types of data we interact with and work with researchers to understand their labeling and annotation needs, the better the tooling can be. So while Miriam has mentioned we've done quite a bit of work with clinical notes, there's still a lot of work to do with video and audio, potentially genetics. So there's just a lot more tools that we need to think about building to support this work in Arcus. So thank you.
Sorry, quick question. So what specific data mining tool? So you're doing all the training. So what specific tools will be available to the researchers in return?
I want to clarify that we are not training. So here if an individual project wants to use Arcus resources to have their machine learning system and train that, we have services for that and we will support it. For the annotation, we are looking at collecting that ground truth or gold standard data. So that big corpus of data that has information from different disciplines, different type of diagnosis, treatment all together, and then allows for sharing and communication across different research projects. But if you are interested in using Arcus for your workflow, then we can have a separate call talking about the tools that Arcus can provide and from the machine learning or statistical approaches that you can do inside Arcus, if that's helpful.
Okay, no, that's helpful. All right, thank you.
Yeah, sure.
Yeah.
Please reach out.
And yeah, if I can just jump into just to clarify too, like how the Arcus archives works, because for the data that we'll be collecting, it'll be part of the Arcus archive. So we take, all sorts of different research data or data from research groups, and we preserve it in preservation compliant storage, and then it's made available through the Arcus cohort discovery, and then also through the gene data catalog. So anyone can search that data and then they can request to reuse it. So it's not exactly data mining, it's more collecting and having information about it and having it all in one place so that people at CHOP that are interested in this work are interested in reusing data or using lots of different modalities from data. So maybe they have their own data, but they want to combine it with other things or with clinical notes or something that they want to request. It's kind of like consolidating, so it's easy to find and that you can kind of pull things together and kind of supporting that type of work that happens a lot within like machine learning and AI research. So yeah, we're not exactly mining it, but we're collecting it together and preserving it. And then if somebody sees it and would like to use it, they can request that. It would go into an Arcus lab. And there's also a privacy team. So, they'd have to go through some privacy reviews of what they're able to see, how they're able to use it, possibly IRB approval and everything. That's part of our process too, before we actually share that data.
And there's a question in the chat regarding tools and standards for pathology and imaging report, and asking if Arcus has any tools for that. So we have that data available, and we can make it available to anyone who requests that through an Arcus lab. So you will be able to see radiology reports, impression findings, depending on how it looks like for your cohort. And you can use that data, which is stored in a relational database system, for your machine learning endeavors, if that's something that you want to look for.
Just one quick thing to add to that is that we have been supporting a number of projects to do annotations. So this is, of course, bringing that to the front and seeing if there's more we can do there, but then also trying to collect that data, whether it was made within Arcus or outside of Arcus. So the annotations we would like to collect as part of this initiative don't have to have been created inside of Arcus.
And then I see another question in the chat from Elizabeth Frau. She's asking if a PI contributes data to the archives, would future requests come to Arcus and then to the PI or study team that contributed their data? And so the requests would come to Arcus, and we have like a process for requesting it, as I mentioned, and kind of reviewing the requests, of course, to make sure it's compliant with any sort of like privacy or other regulations. Usually any restrictions in terms of reuse come from like protocols, from study protocols. You know, if the PI and team would like to be contacted when somebody requests their data, or if there are like other restrictions that are needed, we kind of customize that per research study.
Any other questions or comments? Okay, great. Well, as I said, please feel free to reach out if anything comes up after that you didn't think of just now. And we're here to help. So, and I saw Allison popped the email address and the link to the form in the chat. So please feel free to reach out to us. We're here. And I hope everyone has a good rest of their day. Thank you again for coming.